Hi, this is Matt from Istanbul. The subject of this video is design patterns. So the thing with design patterns is that most books that talk about it, they weigh at least 2 kilos. So it's a little bit intimidating and you think, oh my god, that looks very complex. Actually, it's not, as long as someone explains it simply. Some of those design patterns, they have very scary acronyms such as RAII, which stands for Resource Allocation is Initialization. It's a C++ pattern that just means allocate resources inside a constructor, deallocate them inside a destructor. So that's quite simple. But there you go, there's a 4-letter acronym to describe it. So one very basic pattern is the adapter pattern, which is quite it's actually used as a starting point for plenty other patterns. So the adapter pattern, what is it? Well, let's imagine that you have a large application inside your suite of applications. You have a large app that uses one logger library. It's your own logger library, and then you hire a new guy, and that new guy comes along and says, hey, I know a brand new fancy logger library that writes logs in red and orange instead of just black and white. So you think, oh yeah, cool, let's use that new fancy library. Okay, let's go. Now the problem is that this new fancy library, when you call it, instead of calling and writing something like log info, it's a slightly different method name. It's called log, and then the list of parameters is not exactly the same, and then you use different types of enums. Well, it is slightly different, but it's different enough for you to have to go and modify all the call sites inside your application, and there are maybe something like 200, 300 places inside your app that call that call your existing logger. So what do? Well, you can use the adapter pattern to make the change easier. So what you have to do is that you have to first extract an interface from your logger library. Okay, so you take your logger library, you extract all the methods from it, you make that an interface. Okay, you instantiate, so that then your application is just going to know the interface, not the actual logger class. You're going to instantiate some class deriving from that interface somewhere inside your application, only once. Okay. So now you've got an interface, you've got the your logger library. Now you want to introduce the new fancy logger library. So what do? Well, you've got your interface here. This is the new fancy logger library. You're going to create a new class that implements that interface and that derives from the new fancy logger library. That derives from it or that owns it. Okay, both are possible, doesn't matter, both work. And now the idea is that you're going to have to implement each method of the interface inside your new class. Okay, and for each one of the methods, which are methods of your interface, you're going to map each method to what are the methods of the new fancy library. Sorry. And I need water. Do you have water? Would you have a bottle of water? Because I've been talking in front of the camera for 15. Yeah. You don't have water? But it doesn't matter. It's okay.
Okay, I don't understand you.
That's okay. Sorry about this. Thank you. Thanks. Sorry about that. So you just instantiate that new class that implements the interface, derives or owns the new fancy library. And then that's it. Now, when you instantiate the class, the object of the class inside your application, well, your application is going to start using the new fancy library, and of course the change is much easier because you don't have to go and change the 300 call points where your application was calling the logger. So yeah, there you go. That's how you use the adapter pattern. It's fairly easy. It's fairly simple. It's very useful.
T'as un photographe qui t'a fait des grimaces dans le fond.
Ah, ça c'est bien.
Quand tu y es passé.
Ah, c'est très bien.
Tu veux être seul de parler à de ce sujet technique de par le monde comme ça?
Oui, c'est... Ah, ben j'avais loupé un minaret. Il manque un minaret dans le... Voilà.
Oh, voilà.
And then you have the Singleton pattern. So the Singleton pattern, the only interesting thing I want to say about it is when you apply it to C++. So the purpose is to prevent the creation of more than one instance of a particular class. A logger would be a good example. Now, in C# it works very well the way we usually implement it. So the way you implement it, you use a static variable inside the class to keep track of the fact that you created an instance. In C++, there's a little caveat. If your logger, for instance, is inside a separate DLL and you're using it from an executable, when you run your process, the process is going to load an executable and a DLL. Now, in Win32, it turns out that the scope of a static variable is the code within the DLL or the code within the executable, but not the whole code within the whole process. So you're going to end up with two instances of your logger. If you attempt to create one inside the DLL, another one inside the executable, you're going to end up with two instances. It's a little bit tricky, it creates bugs, you need to be aware of that. That thing behind me is a hippo. So back in London, this behind me, this is St. Paul's. The next patterns I'd like to talk about, dependency injection, and the pattern that usually dependency injection works with, which is the registry pattern. So another pattern with a weird name, dependency injection. What is it? Well, it's the idea that, let's imagine that you've got a program that accesses a database, and then you manage to encapsulate all the database access inside one single gateway class. And then you want to start unit testing your application. So you would like to replace that gateway database class with a mock gateway class that would just simulate the database access in memory only, so that you can run unit tests fast in memory, which is what you want. So what are you going to do? You're going to create all your client classes that use this database gateway, and you're going to inject the concrete instance of the gateway to the client classes. So you're going to do that either by the constructor or by a setup property or directly from the code side, and that's where we usually use the registry pattern. So the registry pattern, the idea is very simple. You just say, okay, I am the client program, I want to get whatever concrete object was registered against that particular interface. This is the interface, give me the concrete object. And so as long as you instantiate your concrete object in advance, before you create your client classes, then it's all good. So why are you doing all this? Well, it's very simple. You just want to be able to automate your unit testing. And you will not be able to automate your unit testing if it does anything else than just accessing memory. If it accesses a database, accesses a network that might be installing because there's wind, if it accesses the file system, or if it accesses another system inside your organization, then that breaks the automated unit tests, because they're going to become slow, they're going to become brittle, and they are really integration tests, which are separate category of tests, but not unit tests, because you want. So that's it for dependency injection and the registry pattern. To be used wisely, there's no reason to use that systematically and all the time, because it's cumbersome. So it's to be used only for those objects you want to mock in the context of unit testing. That's when it makes sense.